Hello everyone, in this video we are going to talk about trigonometric graphs and their transformations. So let's look at what are the graphs of sine, cosine, and tangent. These graphs are all periodic, which means they repeat themselves after a certain interval. Now let's look at y equals to sine theta. So here is y-axis and here we say that it's theta. So when you want to draw the graph y equals to sine theta, we know that the value of sine theta is between 1 and negative 1, which means the maximum value of sine theta is 1 and the minimum is minus 1. Sine 0 is equals to 0. Sine 90 equals to 1. Sine 180 equals to 0. Sine 270 equals to minus 1. You can type this value into the calculator, and for the 360 it's 0, and 450 is 1, 540 that is 0. And for the minus 90, that equals to minus 1. For minus 180, that is 0. So we can see it is a kind of wave of the sine graph. Now we can use a wave to draw this point together, to link these points. That is look like that. So that is a graph of y equals to sine theta. That repeats every 360. As you can see. Start from 360 is another wave. So we said that it repeats every 360 and crosses the x-axis at minus 180, 0, 180, 360, 540. Now, how about y equals to cosine theta? Similarly, the value of the cosine theta is between minus 1 and 1. So the same, the maximum value of cosine is 1 and the minimum value of cosine theta is minus 1. Then you type the degree into your calculator, you will get that cosine theta equals to 1, cosine 90 equals to 0, cosine 180 equals to minus 1, cosine 270 that equals to 0, 360 that equals to 1, 450 that equals to 0, 540 that equals to minus 1. For the negative 1, so when you type minus 90 that equals to 1, and minus 180 that equals to minus 1. So there is another wave. So the graph of cosine theta looks like that. we can see it also repeated over 360. Right? At the beginning, we start at y equals to 1, and at the 360 degree, there is another one. So we say that it repeats over 360. The differences between the cosine and the sine, you can see that if we said that theta equals to 0, sine theta starts from the origin, but the cosine theta starts at the 0, 1. So if you want to draw sine theta and cosine theta, you can start from the different points when theta equals to 0. Now let's look at the graph of the tangent. Unlike the graph of sine and cosine, y does not have the maximum and the minimum value. Well, for some values of theta, the value of y is undefined. Since the graph of tangent has vertical asymptotes, those asymptotes are theta equals to 90 degree, theta equals to 270 degree, theta equals to 450 degrees, and also theta equals to minus 90 degrees. They are the vertical asymptotes of y equals to tangent theta. You can see that between two asymptotes, the interval of them is 180 degrees. Which means if you want to draw the graph of tangent, you just need to know one asymptote and then you can draw other asymptotes. For example, if you know that theta equals to 90 degrees is an asymptote, and you plus 180 degrees, there is another asymptote, and you minus 180 degrees, there is another asymptote. You can do that repeatedly. Now let's draw the tangent graph. If you type theta equals to 45 degree into the calculator, you will get a possible value, probably look over here. And then if you type 75 degrees into the calculator, so tangent is 75, that is larger than the tangent 45 degree. We can see between 0 and 90 degree, the graph increases. Now, if you type minus 45 degrees, the tangent minus 45 is negative. If you type minus 75 degrees, the tangent minus 75 is less than tangent minus 45 degree. So between 0 and minus 90 degree, the tangent theta decreases. Be aware that we also have the vertical asymptotes at theta equals to 90 degree and theta equals to minus 90 degree. So the value of y get close to the asymptotes, but never touch them. So we can draw the graph like that. as you can see, in the interval between minus 90 degrees and 90 degrees. On the right hand side, so between 0 and 90 degrees, the graph increases, and between minus 90 degrees and 0, it decreases. Now you can repeat the drawing of that. So the graph of y equals to tangent theta, it repeats every 180 degrees. So in another 180 degrees, it is the same graph. Another 180 degrees, that is the same one. So between 450 degrees and 540 degrees is negative. Between minus 180 degrees and minus 90 degrees, that the value of y increases. You can see that the graph repeats every 180 degrees. So here is a graph of the tangent. Now let's look at all the graph. Here is a graph of sine theta and the graph of cosine theta and the graph of tangent theta. Now let's look at some questions. So for the questions, part A, it asks you to sketch the graph of y equals to cosine theta in the interval minus 360 degrees less than equal to theta less than equals to 360 degrees. So let's do it. For part A, we know that the maximum value and the maximum value of cosine theta is 1, and the minimum value that is negative 1. So when you draw that, you can first write down the value of y. Here is 1. Here is negative 1. And probably you can use some dot lines to ensure that you can draw a nice curve. Now remember that for the cosine theta, when theta equals to 0, y equals to 1. So we start from the 1, and then for 90 degrees, 180 degrees, 270 degrees, the interval asks you to draw it between minus 360 and 360. 360 minus 90 degrees minus 180 degrees minus 270 degrees minus 360 degrees. Now we can draw that. So remember that when theta equals to 0, y equals to 1. And then the wave should go down, which means at 0 when theta equals to 90, when theta equals to 180, that means at minus 1, 270 degrees, y equals to 0, 360 degrees, y equals to 1. Now for the negative theta, the negative 90 degrees, y equals to 0. Minus 100 degrees, y equals to minus 1. Theta equals to minus 270, y equals to 0. For minus 360 degrees, y equals to 1. Now we can draw the curve of that. So here is a curve, y equals to cosine theta, and theta is between negative 360 degrees and 360 degrees. So we've done the part A question. Now let's look at part B question. It asks you to sketch the graph of y equals to sine x in the interval x greater than equal to minus 90 degrees and also less than 270 degrees. That's part B for the part 1. So let's do it. Part B, part 1. Asks you to draw y equals to sine x, where x greater than equal to minus 180 degrees, less than 270 degrees. Now remember that the maximum value of sine x is 1 and the minimum value is minus 1. Similarly, we can draw the line at y equals to 1 and y equals to negative 1. So the curve is between two of them. The special degrees we need to remember is 90 degrees, 180 degrees, and then that is 270 degrees. Then for the negative part, that is minus 90 degrees and then minus 180 degrees. When theta equals to 0, y equals to 0. We start from here. So for the curve, it should goes up when theta go along to the positive to the 90 degrees. So when theta equals to 90 degrees, y equals to 1, theta equals to 180 degrees, y equals to 0, and for the theta equals to 270 degrees, that should be negative 1. For theta equals to negative 90 degrees, it equals to minus 1. Theta equals to minus 180 degrees, y equals to 0. Now we can draw the curve. Yeah, like that. So we've done the part 1. Now let's see what the part 2 question asks. The question told you that sine negative minus 30 degrees equals to minus 0.5 and asks you to use your graph to determine two further, sorry, I wrote down the wrong word. Two further values. To determine two further values of x for which sine x equals to negative 0.5. We know that sine negative 30 degrees equals to negative 0.5. So we can draw the line y equals to negative 0.5. Here is y equals to negative 0.5. It tells you that sine minus 30 degrees equals to minus 0.5. In here, we know that theta equals to minus 30 degrees. And we can see there is another two further points. One is over here, Another one is over here. Now we want to find these two values. So let us find these 2 points. You can see that between negative 180 degrees and 0, theta equals to negative 90 degrees is a symmetric line. Symmetrical line. Right? Just between negative 180 degrees and 0. The curve is symmetric. Let us say this point is P1, and the point we know that is called P. Since theta equals to negative 90 degrees is a symmetrical line, the distance between negative 180 degrees and the value of theta of P1 is the same as the distance between 0 and negative 30 degrees. So these two distances are the same. So that is 30 degrees. So for P1, the value of theta should be negative 100 degrees plus 30 degrees equals to negative 150 degrees. Right? Now, let's look at another point. Let's call P2. So, at the same, if you look at the curve between negative 90 degrees and 270 degrees. So in this part, you can see that theta equals to 90 degrees is a symmetrical line, right? Which means the distance between 0 and negative 30 is as the same as the theta of P2 to the 180 degrees. This is also 30 degrees. The distances are the same. So for P2, we can get 180 degrees plus 30 degrees. That equals to 210 degrees. So here are the answer. Now let's move on. So after you know the trigonometric graphs, we can also transform them. Let's firstly quickly recall the general transformation of the function fx. So y equals to fx plus a, which means you move fx by the vector 0a for y equals to f bracket x plus a, which means you move fx by the vector minus a, 0. For y equals to a fx, which means you stretch fx by a scale factor of a in the vertical direction. Y equals to f bracket ax, it means you stretch fx by a scale factor of of 1 over a in the horizontal direction. For y equals to negative fx, it means a reflection of y equals to fx in the x-axis. For y equals to f minus x, it is a reflection of y equals to fx in the y-axis. So this transformation also apply to the trigonometric graphs. Now let us see some example question. So for part A, it asks you to sketch y equals to 1 plus cosine x, where x is between 0 and 360 degrees. For your convenience, I will firstly draw the graph y equals to cosine x. So we have here x, here is y. Let's firstly draw that y equals to cosine x. Have 90 degrees, here's 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. We know the maximum value of cosine x, that is 1. And the minimum value, that is negative 1. So the curve of cosine x is between y equals to 1 and y equals to negative 1. We know that when x equals to 0, cosine 0 equals to 1. So we can draw the curve. We have x equals to 90 degrees, y equals to 0, 180 degrees, that is negative 1, and 0, 1. So we can draw the curve. Here is y equals to cosine x. Now the question asks you to draw y equals to 1 plus. Let me use a orange one. 1 plus, which means you have y equals to 1 plus fx, where fx equals to cosine x. So you know that plus something out of the bracket means you need to move fx by the vertical 0, 8, so in here is 0, 1. So the graph of cosine x moves up 1 unit. Thus, the maximum value of y equals to 1 plus cosine x, that will become 2. And the minimum will be negative 1. Will be 0. Now let's move up. So 1 plus 1 will be 2. And for the 90 degrees, y equals to 0. So 0 plus 1, that is 1. And when x equals to 180 degrees, y equals to minus 1 plus 1, that is 0. X equals to 270 degrees, that is 0 plus 1, so is 1. When x equals to 360 degrees, y equals to 1 plus 1, that is 2. So we find all the points. That are the orange one. So we link them. So here is a graph. Y equals to 1 plus cosine x. Let me erase the dark, black part so you can see clearly of that. Sorry. So the orange one is y equals to 1 plus cosine x. Now let's move on to see part B. Y equals to tangent theta plus 45 degrees. And theta is between 0 and 360 degrees. So firstly, let's draw the y-axis and theta. We have 90 degrees, 180 degrees, 270 degrees, 360 degrees. Let's firstly draw tangent theta, y equals to tangent theta. We know the asymptotes, that is theta equals to 90 degrees, and then plus 180 degrees, that is 270 degrees. This, the black line is a graph of the tangent. So we have the y equals to tangent bracket theta plus 45 degrees, which means you have the y equals to tangent theta plus a. That a is inside the bracket, which means you move let me see, here is 45. You move fx, so fx, move fx by the vector minus 45, 0, where fx equals to tangent theta. So you move the graph to the left 45 degrees. about 45 degrees, yeah. Which also means the asymptotes of tangent theta will also move. We have the new asymptotes that is 90 degrees minus 45 degrees. So move to the left, move left 45 degrees. So 90 minus 45, that is 45 degrees. 270 degrees minus 45 degrees, that is 225 degrees. Here are the new asymptotes. Right? Which also means when you also move the 300, sorry. Now you can type theta equals to 0 into y equals to tangent bracket theta plus 45 degrees. You will get y equals to 1. So between 0 and 45 degrees, the curve looks like that. It still goes up. Now, for the theta equals to 180 degrees, y equals to tangent 180 degrees, that equals to 0. Now you move to the left about 45 degrees, so that is 180 degrees minus 45 degrees should be 135 degrees. In here, theta equals to 135 degrees at y equals to tangent theta plus 45 degrees equals to 0. Similarly, you move 360 degrees to the left about 45 degrees, that is 360 minus 45 degrees is 115 degrees, 350 degrees. So in here, y equals to 0 for tangent theta plus 45 degrees. Now you can draw that the graph of tangent theta plus 45 degrees. So the orange one is y equals to tangent theta plus 45 degrees. Let me erase the black one. So here is a graph of y equals to tangent theta plus 45 degrees. You just move the y equals to tangent theta to the left about 45 degrees. Let's look at part C question. So we have y equals to 3 sine x, and x is between 0 and 360. We know that if y equals to 3 sine x, it means that you stretch fx equals to sine x by a scale vector of 3 in the vertical direction. Now, firstly, let us draw y equals to sine x. We have 0, 90 degrees, 180 degrees, 270 degrees, 360 degrees. So that is between 1 and negative 1. We have the curve like that, so you draw the point at first. And then we link these points. Here is y equals to sine x, that is fx. So y equals to 3 sine x, it stretch fx by a scale vector of 3 in the vertical direction. So we stretch the value of y times by 3. Right? So when x equals to 0, y equals to 0. When x equals to 90 degrees, it will become 1 times 3, probably over here, I guess. So here is 3. And for the 180 degrees, y still is 0. For 270 degrees, negative 1 times 3, that is negative 3. And 360, it keeps 0. Now we can link the orange point to the curve. The graph of y equals to 3 sine x looks like that. You stretch sine x by a scale vector of 3 in the vertical direction. Now let's move on to see part D question. You have y equals to sine 2x. Now let us see y equals to sine x, that is fx. So y equals to sine 2x, which means you stretch fx with scale factor in here I read wrong, that is scale factor of 1/2 in the horizontal direction. Right? Let's firstly draw the graph of y equals to sine x, so fx. You have x that is 90 degrees, 180 degrees, 270 degrees, 360 degrees. So between 1 and the negative 1, we have the points of that for the sine x. So here is a graph of sine x. Now, for y equals to sine 2x, it means that you stretch fx with a scale factor of half in the horizontal direction. You know that the periodic of y equals to sine x is 360, and you stretch this period with a scale factor of half, which means it repeats let me change the color. It repeats every 360 times half, that is 180 degrees. The graph of sine 2x repeats every 180 degrees. So we can have that. You can finish one period, so one cycle of the wave in 180 degrees. Thus, we can draw that at x equals to 45 degrees is 1, and 90 degrees is 0, and 135 degrees, that is negative 1, and 180 degrees, that is 0. So we have the curve like that in one period, and we repeat it in another period cycle. Another cycle, we have 225 degrees, right? Yeah, that is 1, 270 degrees is 0, and 350 degrees is negative 1, 360, that is 0. So we link them. Thus, we have done the graph of y equals to sine 2x. So here is 45 degrees, here is 135 degrees. Let me erase the black one to see it clearly. Now move on to the part E question. It asks you to sketch y equals to negative tangent theta, where theta is between negative 180 degrees and 180 degrees. Let us see y equals to tangent theta, that is fx. Maybe, let's see f theta. And here is theta. So we have y equals to negative tangent theta is a reflection of f theta in the x-axis. Now let's quickly draw y equals to tangent theta at first. Oh, sorry. We have 90 degrees, 180 degrees, negative 90 degrees, negative 180 degrees, 0, y, theta. So the isotopes for y equals to tangent theta is theta equals to 90 degrees, negative 90 degrees. Then you can draw the graph. Like that. For y equals to negative tangent theta, you reflect f theta in the x-axis. So for in the x-axis, in here is theta axis. So you reflect theta axis. We have that between 0 and 90 degrees. The reflection of that looks like that. And between negative 90 degrees and 0, it reflects like that, right? And similarly reflect other places. So the orange part is a reflection of tangent theta in the theta axis. Now let me erase the black part so you can see it clearly. How does the y equals to negative tangent theta looks like? Now let us see if the negative is in the bracket, that is y equals to tangent minus x. We say that y equals to tangent x is fx. Thus tangent, this y equals to tangent negative x is a reflection of fx in the y-axis. So firstly, let us draw the graph of y equals to tangent x. Beware between negative 360 degrees and 360 degrees. So we have 90 degrees, 180 degrees, 270 degrees, 360 degrees. Here is x. Let me move this part a little bit. Sorry. Yeah, now you can still see it. Here 360 degrees and negative 90 degrees, negative 180 degrees, negative 270 degrees, negative 360 degrees. So here's y. Firstly, draw the isotopes. That is 90 degrees, 270 degrees, negative 90 degrees, negative 270 degrees. So we can draw the graph of tangent. For y equals to tangent negative x is a reflection of fx in the y-axis. So for the y-axis, now look at the graph between x equals to 0 and 90 degrees. It reflects this part, in the y-axis. So we have the curve looks like that. And between negative 90 degrees and 0, we reflect this part. we have the curve like that. Now let us draw the reflection between negative 270 degrees and negative 90 degrees in the, so reflect it in the y-axis. What we have the graph looks like that. Yeah. And for the curve, the graph between minus 360 and minus 270, we do the reflection. So the graph on the right hand side, that will be looks like that. Now similarly, we do the reflection of the right hand side. So do the reflection between 90 degrees and 270 degrees. We have a graph like that. For the curve between 270 and 360 degrees, we have the curve looks like that. This, the orange part, is y equals to tangent negative x. Now let me erase the black one to see it clearly. So the orange one is y equals to tangent negative x. So we have done all the questions. The important thing for the transformation is that you need to remember the general meaning of that, and then to be aware the change of the values. So in part A, it changes the value of y, and for the tangent graph, you also need to be aware of the asymptotes. And be aware of the change of the period, yeah. Okay, here is the end of the lesson. Thank you for watching.